Let's take a piece of brass and turn it into this Fusion F using a Tormach 440 and a set of these monster jaws that when we're done are going to look like this. So why do this? Well, first of all, I think it's pretty awesome. We use Fusion 360, 2-position soft jaws, and make this cool part. But I got to share this with you. I'm so excited. Autodesk is partnering with Tormach to host the first hands-on machining class at Autodesk University in Las Vegas next month, and they asked us to come teach the class. It's one of those moments where you're like, this is awesome. Like, you kind of feel like you're starting to make it. So we're super excited. We normally do this as a 3-day class. It's going to be a 1-day class. If you're coming to AU, link in the video description where you can sign up for the class. So we got to have our ducks in a row. So let's take a look at the Fusion 360 code quickly. We'll look at it more in depth at the end, and let's make some chips. Welcome to another Wednesday Widget. The Fusion F actually came from, if you scroll all the way down in your data panel, there's this workshop and events, but there's also some really good stuff. Check this out, folks, like canned samples, really good. And so that's where we grabbed the Fusion keychain. Here's what I like about this little project. We've got one set of soft jaws with the 2 stations. So we've got an operation here where we're going to machine the soft jaws. Then a piece of raw material will go in the, let's see here, turn this on, in the left side. And take a look, the soft jaws are in the current position to handle this second op, but how this works is we've got the same work coordinate system, and it's based off of the rear jaw or the fixed jaw. So this front jaw is going to open up more, but it doesn't matter because I've still got the stock and part modeled in place. So the first thing we'll do is face it, adaptive profile it, clean it up, drill, chamfer, trace our logo on the back. Then we've got the shape cut out, flip it over, put it in the station over here, and we'll do a 3D, God, I love this toolpath, 3D adaptive, just amazing. We'll clean up a little bit. I can turn that side on. Parallel op and chamfer like so. So I think that's pretty cool. Let's go make some chips. Stick around at the end. We'll go through a really detailed walkthrough on all of this stuff. We'll also make this F3D file available. Normally we like to ask that that's only for folks that support our channel on Patreon, but link in the video description if you want to download this and take a look at the whole thing. It's obviously really important to have the soft jaws spaced apart the same distance they were in CAD. We had these spaced apart 1/8 of an inch, so we're going to use a 1/8 inch gauge block. If you don't own gauge blocks and you need a distance, especially a really custom one, just use a drill. Odds are you're going to be able to find a drill that's either spot on or really close. All right, folks, we're going to let the GoPro run this whole time. We'll do 2 things. One, it'll prove there's no shenanigans here. We never change our work coordinate system, or reuse the Heimer. And we'll see how long it actually takes. We'll probably fast forward the footage, but it'll at least give us a start and end, no BS time. Including all the tool changes. I cannot wait for the power drawbar. Supposed to be out any day. I'm not gonna lie, I really like this 440, but the fact that they haven't gotten the power drawbar out yet is a little frustrating. I suppose you could say we're spoiled these days, but it's gonna make it a sweet little machine. Drilling holes for our Mickey Mouse corners. The other interesting thing, we're making the soft jaws here in Zanesville. We'll ship them out to Las Vegas, but in Vegas, we're not gonna have any coolant. It's just, we're cutting brass, and coolant is a lot more hassle factor with liquids and setups and leaks and air compressors. So we're gonna run this all dry, which will be fine, but so we're gonna run it dry today as well and see how it goes. I should clarify, we're going to run the brass dry. We'll use some coolant here on the aluminum. 10K RPMs, 21 inches a minute. This is slow. I think Jared programmed this, which is fine, but we can go faster. I just did the feed rate override to 150%. It's kind of funny, we're filming this, let's see here, the day after we announced the Haas BM3 purchase, and I am so excited for that, like just beyond excited. On the flip side, I gotta tell you folks, this 440, especially when the drawbar and tool changer comes out, it is like a sweet little machine. I'll be curious to see how the work gets split and how I use what, but you know, setting this thing up and letting it bang out parts is actually pretty awesome. It really is. We've also had a bunch of people ask us, in fact, it's always been a popular question, but today I had two good friends ask me about buying a used BMC, an old one, and I think that deserves a whole video. And of course, I've got my opinions, but that's what you should do if you're in that market. You should gather the facts from people. But one thing I will say is, don't take for granted how awesome PathPilot is, how easy it is to use, how well it can handle modern G-code and high-speed machining, and just the ease of use. There is a lot to be said for that. It's actually kind of funny. I think this is the first time I've ever really blindly ran somebody else's code. Jared already made most of the soft draws. I told him to leave me a set to film with. And look, Jared knows this stuff. Jared knows what he's doing. But it's just kind of weird because there's so many little nuances to how you program. So that was weird. I've never actually had that problem. But the spindle just stopped working. I just had to turn the machine on and off. Annoying. I wonder why. Maybe we got to update our PathPilot. I'm not trying to make an excuse. It's just weird because I've had these machines a while now, and there was a spindle glitch in the very beginning with these machines, but it got fixed. I don't know. Anyways, what's nice is turn it on and off. The limit switches work. They repeat. Honestly, I don't even trust my 1100. Like I always find 0 here. I just turned it on and off, re-ref 0, and we're running the code again. And you can see from how it's cutting that we're good. I have feed rate override on, so something blue always goes on the machine. That's the reminder. Usually it's a blue hose, but I don't know where the blue hose is. This is just a 2,000th of an inch chamfer, really just an edge break, or your sharp edge break. It's beautiful. When you actually see it up close, it's like just that little bit of shiny aluminum where it's cutting. Boom, we're done. Okay. So, pull out my 1/8 inch stop pin, grab a piece of raw material, slide it up. So the dilemma here, is there a chip in there? There we go. We had to hang it off a little because we didn't have enough room in, oops. We didn't have enough room to fit this whole chunk on there, but that's fine. Really, no big deal at all. One tap. Just beautiful. Oh my God, I love it. I love it. See that? I think we downgraded this path pilot for some reason. Maybe we were doing something, because there's actually now a little delay, because this spindle takes a few seconds, actually like 5 to 6 seconds to ramp up, which is a bummer, but you notice there it went into the cut before it ramped up all the way. So I think that's maybe why. I think I just exposed a bug that's already been fixed. My fault. So here we're going to use a 3/16 mil drill. This is actually a spotting one, which is not quite the same. The tool I want to use I just ordered from Carl over at Lakeshore. This will work. Oh, actually this will not interpolate. We'll see if it could be a problem here. Might. Let's see what happens. We might crash it. We might crash here in full disclosure. No. Nevertheless, not ideal. But the idea here is to show using the same tool for multiple different functionality. And a quick chamfer. Actually, in fairness, that's probably like the first time in 5 years that I've actually chamfered, milled, and drilled with one of those. And engraving our logo on it. I had to stop and change the code real quick because Fusion right now doesn't let you post out with 0 RPMs. Al was saying that they can fix that, because with this tool it works better when you don't rotate the spindle at all. So the idea here is we'll brush it off. I can get some paint brushes for class. Pull this out. Flip it over. Make sure we're seated. Sounds solid. And back to tool 31, which is the 1/4 inch end mill. Woo, look at that go. Isn't that awesome? No coolant. Look at that natural chip evacuation. Awesome. Horizontal, just to clean up the little key ring section. Love it. God, you guys remember anybody doing this at the hobby level in like 2000 and 2007, 2009? There was like no good options out there that weren't. I mean, there's just, oh my God, I sound like an old man, but you take it for granted how awesome it is to use Fusion and get the ease of use and the quality of the tool pass, integrated CAD CAM, cross-platform, used on my Mac and my PC. Okay, 3/16 ball end mill. Let's do some surfacing here. Like I said, first thing I'm noticing there is some air movements. I'll take a look at the tool pass. Well, we'll do it together and see. I suspect I can clean that cutting up. Unless I'm misunderstanding and this is an adaptive. Sometimes we'll do an adaptive at a slower feed rate before we go in and do a real fine step over to get the finish. I just went and looked. That's exactly what it is, which is awesome. The adaptive with the Tool 31, the flat 1/4 inch end mill, can't get everywhere that this little 3/16 ball can, and that's the tool that we're about to use to go surface this. And when we surface it, we want constant chip flow. We want to go faster. We want to avoid introducing that cutter to a big chunk of metal that wasn't removed from a prior operation. So by doing a 3D adaptive with rest machining, we can control the feed rate and let this cutter come in more, slower feed rate or more controlled feed rate, get rid of the stuff that's left, and then here in a minute we'll see it does the parallel and it's smooth sailing. It's not going to hit any surprises. Here we go. Here's the parallel. Yeah. Some of the guys that did the sort of Kurt Chan Fusion 360 Cam Challenge who just crushed it. Oh my God, these guys crushed it. Did a really cool, I think it was an adaptive step over where, I didn't even watch. I assume they lied and told that it was say a 1/4 inch flat end mill in cam, but then they actually used like a 3/16 ball, and you got this step over pattern that just looked beautiful. It was some of the nicest looking parts I've ever seen. So kudos to them. And that's kind of the funny thing, like when when people ask me about Fusion 360 and rightfully ask questions or don't know about it, I just think where this is going, where this is even going to be in another year from now, because you got so many awesome people that are using it, that are sharing their experiences. We're not the only one putting videos out on Fusion or success stories. The forum, the Instagram community, it's incredible. It really is incredible. Awesome. I think we're done. Actually, you know what? I think there's a chamfer. I lied. Chamfering the ID of that hole. Oops. Oh shit. I'm gonna stop that. That's operator error. I did not have the tool fully seated. I've not made that mistake in a long time. This is what it should have done. And now chamfer the outside of it, which this should look okay. Yeah, that's better. Using a 2D chamfer to avoid touching the solid model where it's not supposed to be chamfered, which is an awesome fusion feature again. So no coolant and soft jaw to finish part. The GoPro, it's looking like this is, you know, I don't know, 45 minutes or so. I think that's awesome. I love it. Logos on the back. Parts right there. Awesome. Just, we live in a great world, folks. This video is running long. We'll make the Fusion detailed video, a separate video, the card to that right here. Otherwise, thank you, folks. See you next Wednesday.